Good afternoon, everyone. It's just gone 2 o'clock, so if it's okay, we'll give people another couple of minutes to drop in. Looking forward to getting started. Okay. Good afternoon, everybody. Thanks for joining. I'm sure after a little bit of lunch, you can sit and listen to me for a little bit and put your feet up. So today we're going to talk about improving operational performance with a digital twin. I'm not suggesting that I have all the answers, but hopefully it'll give you some things to think about and maybe allow you to go back to your business and have a look at some of the things that you're doing. But it'd be nice to have some some questions and answers at the end. So in the usual format, if you just want to pop them in the chat, we can maybe pick those up at the end. It's quite an interesting subject. So just to start off with who I am, I'm Rob Charlton. I'm Chief Exec of Space Group, but also Director of Twinview, a project that we've been working on for the last probably 7 years now. I'm an architect by profession. I've been in the industry for, well, difficult to say, but well, it's actually 30 years, I think now. So it's been, seems like some time, but it only seems like yesterday. And I'll give you a little bit of background to Space Group, which Twinview is part of. It's not supposed to be a sales pitch, but quite useful, hopefully, for a bit of context. So we've been around 65 years. We're a long-established business. Started out in the northeast of England, but now work across the world. But started out as an architectural practice. Well, then probably about 15 years ago, we got very interested in the digital side of the business after, in 2020, starting using Revit in the architectural business and saw the value. So we set up a digital consultancy called BIM Technologies, which works a lot in London from information perspective. Got some great clients, things like the Google King's Cross building we're working on. Got some great projects with GPE, Argent, Derwent, and all those kind of companies. And then we've got BIM Store, which is a library for components that go into buildings, so engineering components like boilers, radiators, but also furniture. And then most recently, we launched those two businesses in 2010, but probably about 2017, we realized that a lot of our clients had some fantastic models and they wanted the ability to use them. So we started off developing a cloud-based viewer, which then over the next year or two evolved into a digital twin. And now, several years later, it's a fully functional digital twin with IoT devices, with a FM platform all built in. So while this is for businesses, they all interconnect with the same ethos and purpose of what we're trying to achieve. And it all fits around trying to improve buildings one way or another, whether that be in design through to construction, and then more recently with Twinview into operation. So they're all sort of based around that challenge that we all face, on the basis that we all know there's definitely room for improvement. So today was to talk about specific operational aspects of buildings, and then how a digital twin could help with that, and the impact it has. Digital twins are relatively new to the property sector. I'd probably say over the last 2 or 3 years, it's become very much the in thing, shall we say, as much as BIM was 10 years ago. I think digital twins are the in thing. And as is always the case when that is those sort of things happen, people like a definition. So the definition that seems to be the most appropriate for us is the one at the bottom right-hand corner there. A digital twin is a virtual representation that serves as a real-time digital counterpart of a physical object or process. To be honest, from our point of view, the definition isn't that important to us. What we're really interested in is the value that a digital twin can bring to business. But it is ultimately a digital representation of the physical, and it's how you use that and generate value for our clients that's all important. So just to use some examples of other industries of where digital twins are used, and probably the best known is around in the aerospace sector, where GE use engines and digital twins, the jets, to track them all over the world, exactly how they're being used, when they need to be serviced, the power they're generating, with thousands of sensors. So they probably are the best example that people refer to. But another one which is very is far more, I guess, sort of domestic and understanding for people is the Formula One car, and how we all see, if we're watching Formula One, all of the data that's coming through to those in the pit lane, and the monitoring how it performs. They use that information to how to develop the car going forward. So that's probably the nearest, most familiar example to us all on a day-to-day basis. And if you can imagine how Mercedes are using that data now to try and get Lewis Hamilton's car to be competitive, that data is all important. So the digital twin is essential to their success. So I'm just going to touch on how the whole the world and everything we do over the last 40 years, how things have progressed, because sometimes 40 years doesn't seem like that long ago, but when you start to see what has been happening, I've picked out a few examples of progress over that time. So on the left is a good old-fashioned thermostat, which you turned up and down, and 30 degrees is hot and 15 degrees is cold, and everything else that sits in the middle, to where we are now with the kind of intelligent thermostats that we have now, that have inbuilt thinking, machine learning, to optimize the performance of your heating in your house. And then in relation to cars, you've gone back to the 80s. Our cars were pretty analog. This is a Japanese car on the left that was very much at the forefront of technology at its time, to the car on the right now, which is a Mini, which I drive a Mini, and it's, I have to say, it's like driving a computer at times. It's an electric Mini, so it's got lots of technology in it, and it's a long way in that 40 years of progressing to how cars are today. And then if we sort of look at our own industry and buildings, on the left-hand side, we've got a typical boiler. Some buildings still have boilers like that in them, but it was more about being managed with a spanner and a hammer and an oily rag. Whereas today, our buildings are powered and managed by increasingly sophisticated systems. And our buildings have got more and more complex during the same time. So digital twins, the why, because often people can forget the why when they get all excited by technology. So always for us, the technology is a means to an end. The digital twin has to develop and offer value. So if it's not offering value, it's just really clever technology. So the value always comes first for us, and the technology enables that value. So that's always the area that we are particularly focused. But the why, there are two real whys at the highest level. What are the challenges we face going forward as an industry? And I'm probably repeating, well, I'm sure I'm repeating information that everyone knows, but it does set the context. So we have to hold global temperature increases to well below 2 degrees. And we're aiming for 1.5 degrees, which is quite a challenge. I think importantly as well, for us as an industry, we have a huge part to play in that, because buildings account for 39% of carbon emissions, whether that be the 11% during construction or the 28% in operation. But the other thing to bear in mind are some of the specific, more closer to home challenges that we face. So our government have set some quite challenging targets, and actually have gone beyond the 2050 targets that many other companies signed up to as part of the Paris Agreement. So we've set ourselves a target of reducing carbon emissions by 78% by 2035. Also, 78% is an odd number to pick up with, but anyway, so that's quite a challenge, and actually 2035 isn't that far away. And then importantly, if we're getting even more closer to home, everyone will know that's involved with commercial property. There are some thoughts afoot from the government around commercial property and EPCs and the impact that the government wants to have on that sector. And we're waiting, I think it's out for consultation at the moment, but by 2025, some decisions will be made. And that sits around by 2027, all commercial office buildings, if from a rental point of view, have to be an EPC B, and by C, by 2027, and by 2030, they need to be an EPC B. And just to put that into context, only 12% of current commercial premises have an EPC rating of B or above. So the implications of that are significant. I do think as the challenge on carbon emissions increases, there'll be more and more legislation to try and hit the targets by 2035, because progress is happening, but is still slow. It is moving, but not maybe as fast as I'm sure government would like it to. And then the other area, which is very close to my heart at the moment, which I'll explain a bit further, but is around energy costs. And this is an extract from last week's wholesale energy costs, which you'll see there's a huge rise. If you go back to 2019, energy costs were down at 2-3 pence a kilowatt. We're now looking at, last week they were at 38 pence a kilowatt. So that is an enormous increase over the last 2 years, 2-3 years. And the impact of that on businesses is huge. So getting down to real brass tacks and the importance of understanding our buildings, the cost of that is certainly something to focus minds. So then I talked about value and where a digital twin can offer that value. So today we're sort of talking around optimizing operational performance, which is how a building works, and reducing waste and very importantly cost savings, but also reducing carbon. Improve productivity, so how do people use the space, how do they feel when they are in it, so understanding more about that. Sustainability and resilience, all around carbon and reducing the use of carbon, greenhouse gases, and then space utilisation and how space is used. So all of this can be addressed or certainly helped with the use of the digital twin. So it's a bit of I guess it's a cliche and is used many times. It's a quote produced by Peter Drucker. If you can't measure it, you can't improve it. And I think digital twins really align with that. I think that's an important part of a digital twin. And probably the biggest thing a digital twin does is it helps you understand your building and gives you data which maybe you might not have had before. So from our own personal point of view, and I touched upon sort of how it was very much focused on my mind at the moment, energy costs. And this is Spaceworks, which is where it's Space Group's headquarters. We were budgeting our energy costs, and we've just started a new budget in January, and we've done some predictions on energy costs. And last year we looked at 2021, and the energy cost was £45,000 for our building. It's a 30,000 square foot commercial office building. When we've looked at our new agreement with our provider, the projected energy costs are near £120,000. So that's 165% increase. So as a business, that really focuses the mind. And our building isn't huge; it's 30,000 square feet. But the impact on business, taking the carbon aspects to one side, the cost is huge. So if ever there was a value driver for something like a digital twin, it gets more and more significant. And then just another thing to touch on from a personal perspective from our building, one of the things we did very early was to sort of understand our building. We've set ourselves a target to be carbon neutral by 2023 and zero carbon by 2030. That's including all three scopes. So the first thing we needed to do was to understand our buildings, and that's where we sort of use a digital twin to try and do that. A lot of it, as you probably would expect, this is not our building, because actually our heating is much lower than that. Where our main cost was around lighting, which was a bit of a surprise. So that's the area we tackled first. So we completely stripped out all of our existing lighting and put LED lighting in, and we've got about a 2-year payback on that. So I think the first statement is to understand your building and understand where you're using your energy, so that you can tackle it. So you can see there, so for example, domestic hot water is only 1%, so probably not the area you want to be focusing on. So probably more likely your heating and ventilation are more impactful areas to focus. So the other area that we've looked at, or I've looked at, is just looking at existing buildings and what the cost of a building is, because I think sometimes it's just something that's accepted on a profit and loss and in a budget of the cost of running a building, but actually it's quite sobering when you look at energy costs. So a couple of months ago we did a bit of research around what the actual cost of running a building would be. So this is we have picked offices in the West End of London, which, as you can imagine, is probably one of the most expensive places on the planet to run a building. But having said that, that is where a large proportion of our current customers are based, so it is a relevant metric for them. So if we take a 10,000 square metre office building, something not dissimilar to what's on the screen on the left, the average operational cost for a building, this is using data that we've gathered from this one in particular from Lambert Smith Hampton, is about £175 a square metre. And of that £175 is £41.50 of repairs and maintenance. And having spoken to building users or operators, in some respects, that's a bit of a surprise to them when you start breaking it down. So just to operate a building is 1.75 million for a building of that scale. And the repairs and maintenance on that building annually is 415,000. So these are big numbers. And there certainly are bigger buildings around the world with huge multiples of that. And then if we look at the energy and the carbon use, rather than just the operational costs, so the average for the commercial real estate sector is 234 kilowatts per square metre. And then looking at the EPC-B 2035 target, to achieve that, buildings need to be down at 55 kilowatts per square metre. And just looking at our building, we've worked really hard and got a very efficient heating system using VRF. We've got LED lighting, we've got natural ventilation, and we get to about 110. So, and I must, from our point of view, how to get down to that 55 is going to be a real challenge. So it is a challenge on buildings, so we really need to understand more about them. So then looking at the overall tons of carbon, so on our calculation, a building, a 10,000 square metre building will have about 723 tons of carbon, and you can work out from that to offset that would be huge. And then if you even want to go to true zero carbon, you need to do carbon removal, which again is going to be expensive. And then the annual electricity cost is £772,000, and that's based on about a 33 pence per kilowatt hour cost. As I said earlier, it goes up and there's differences between your standing charge, but that's probably average. And if anything, it's only ever going to go one way. But 772 is a significant cost. And then also looking at buildings, sort of understanding how they're used by the people in them. I think often we talk about building efficiency, and there is building efficiency, but also from a property point of view, but also from the people that are in it. And even just looking at the kind of sickness days, the sickness absence is about 3.6 days per annum. Interestingly, that's come down through COVID. Be interesting to someone do some research for the reasons for that. But if even you took 500 people in a 10,000 square metre office building, you're talking sort of 1,800 days potentially lost. And an interesting stat that sort of I stumbled across not so long ago is that indoor air quality is 5 times worse than external air quality. So now we can monitor that far more closely, and people are a lot more sensitive to air quality on the other side of the pandemic. And then space utilisation, a big part of all of this is how much space are we actually using. And a lot of businesses now are looking at what space they are using. But West End of London, you're probably talking £1,000 a square metre to rent that kind of building. So if you just look at the cost of that, rent is 10 million and rates is about 5 million. So the cost of these buildings is huge. So not to be sort of ignored. And then we add the whole thing together. So your operational maintenance cost of a 10,000 square metre building is a couple of million. The energy cost is nearly 800,000. Your rents are 15 million. You're producing over 700 tons of carbon. All of that adds up to an operational cost of £20 million. So your building is costing you an awful lot of money. And has an impact. That's a pure cost, and that's having an impact on your bottom line. So you really need to understand it, and you need to optimize it. So just looking at, even if you just got a small 5% operational cost improvement, you're going to save £1 million. So these are big numbers. 36 tons of carbon, potentially 90 additional work days. You're potentially going to improve the experience of the people in your building. And then also importantly, as you learn, you're going to be able to improve future buildings. So it's a big topic, this. And the more we know, the more we can sort of adjust and optimize. So how are we managing buildings in the 21st century? It's quite an interesting perspective, this, because it hasn't been something we've necessarily focused on in the commercial real estate or in any buildings, to be honest. So this is sort of how we do it now. Some of it might be slightly more on the negative side, and I'm sure there are some that do things very differently and do them really efficiently. But generally, it is a fairly analog process of how we run our buildings. And to repeat the point earlier, is that actually we have such a low-tech approach to manage our buildings, yet we are 39% responsible for carbon production in the globally. And I think looking at optimisation, I think the reality is that optimisation of buildings could be mistaken for facilities management. And facilities management can be often more of a focus from people's understanding around the soft aspects, such as cleaning, catering, and actually the hard aspects of facilities management, which is around the energy efficiency and how a building operates, probably gets less attention. It just is what it is. And actually, when we look at our buildings and what we know about them, majority of people, companies the best information and detail they have generally comes through their through the letterbox once every quarter, and it tells you how much energy you are using, and actually do people make any significant changes because of that, or do they say, oh wow, the electricity bill's gone up? But the reality is we don't know a great deal more than that. And then just sort of to put it in context, these are huge budgets, and your building cost is probably a £20 million cost. Your energy costs are 800,000, another 400,000 for your maintenance. And actually, in a lot of businesses, we know more about the paper and the stationery budget than we do some things about our buildings, because they've just typically been a line on your budget. And I put ourselves as a business in a similar vein, that actually just accept the electricity cost is what it is, and it just goes as a single line. Once it increases 165%, it certainly puts our board a little bit more focus on it from our board's point of view. And I'm sure as people look at their agreements over the next year need to be renegotiated, it will come into focus a lot more. And then the other side of it, these huge numbers of cost, we're actually subcontracting a lot of that out to a third party. So even these huge budgets are often not managed by organisations themselves. They're put out to a facilities provider, and a lot of this really valuable data that is useful often goes with the subcontractor. So it's fine when you're working with that subcontractor. There is some information maybe that you can access, but if you change a subcontractor, all of that history that you've got leaves with that particular subcontractor. So it's a fairly analog way of managing businesses and buildings at the moment. And then the other side of it is what we do with our new buildings when we're developing them. Most new buildings, certainly in the last 5 years, have very, very expensive building management systems, usually specified by the mechanical electrical consultant, and they're incredibly sophisticated. However, the other side of that is that actually, in most cases, they're very, very rarely used or even adjusted. So this is a good example on the right here. This is probably the engineer going down and having a look at the BMS controls, and it probably happens once every 6 months if it's good, or once every 12 months, or often is put in at commissioning and never touched again. And then the other aspect is the performance gap. So a lot of building users that we talk to talk about the performance gap. It's actually not a performance gap in my view. A performance gap is that it was designed one way and performs a different way. And usually, well, it's always going to cost the building owner more than they thought it was going to be, and that is the performance gap. And I've certainly had clients sort of look at it and say, oh, I'm trying to understand what is the performance gap and why is it there? And the answer is actually quite simple, in that the information that buildings are designed to is inaccurate and probably out of date. And that's something we can get more sophisticated with. And then I just put a note there, if there was a difference between how Mercedes designed their car to when it got on the track, I think it will be a very, very different question. And then when we look at buildings, we're designing buildings, but we're designing without lots of information from previous buildings. We tend to dive in and not use objective information about how we design our buildings. And then also specifying plant. We have plant in our buildings which some works really well, some fails, but generally we don't go back and review the performance of the plant that we've used and specified. So there is a potential of specifying equipment that hasn't performed particularly well. Then move on to servicing and commissioning. The reality is that we don't service our buildings as robustly as maybe as we do with our cars. All of our cars get an MOT regularly, and we do maintain our buildings, but not particularly in a sophisticated way without sophisticated data. So what we do now is we have a planned maintenance schedule, and we maintain plant, valves, filters, whether they're needed or not. And we use SP30, SP30, isn't it? SP20. And that really drives the level of maintenance that we need. So where's SP20 getting this information from? How up to date is it? How specific is it for that particular piece of plant? And if we take a look at our cars, many years ago, we just maintained our cars once every 12 months. But actually now our cars are monitoring when they need to be maintained, and we maintain them. Sometimes we need to do things sooner than we planned, or sometimes later, to optimize the efficiency. And I think with more information and performance data around buildings, there's a chance to do that with buildings, that we may change filters sooner than they need to be, or service a piece of plant because it doesn't need servicing as much further down the line. So there is a real disconnect between the people using a building and the people engineering new buildings, or even engineering them when in operation. So the people that go and tweak the buildings, commission them, are often down in the basement and don't know what's going on with the building. So that disconnect is not giving ongoing feedback on how the building's being used, when it's being used, typical temperatures, areas where it's failing. But we're not getting that feedback at the moment, and we're continuing to get the performance, which can often be below expectations as we go forward. As I said here, that we just continually repeat some of the areas of inefficiency and continue to make the mistakes we made in the past because of that disconnect between the engineer, design, and the occupation. And certainly from a designer's point of view, often the operational side is not given a great deal of consideration. And as an architect, I say that from experience and hold my hand up the same. And I remember several years ago when we were designing PFI buildings, and we had to have the facilities management team on board. And actually at the time, the understanding of FM as an architect was that we had to include cleaners cupboards, and that is the truth of it. We didn't really understand the impact of the building costs and operational costs and things like that. And as I said earlier, sort of monitoring the failed equipment and feeding back in. So if a piece of equipment fails, the subcontractor is probably managing the building and is maybe not fed back that a particular fan coil keeps failing. We haven't got that information. We had an example recently where a subcontractor facilities manager could tell the client that some valves had been changed, but couldn't tell where those valves were. So it's just a lack of knowledge, understanding that we can learn from in our buildings, and something that a digital twin gives us that. And from a design and build point of view, the procurement of design and build is often based around cost, and that is the main metric. And that's no criticism of the design and build procurement process. It has a lot of value, and it moves risk from the client to the contractor. Successfully puts the risk probably in the right place. But because of that, it's the main metric is cost, not value. So what that means is that if a client wants specific operational performance, that needs to be specified at the beginning to make sure that the decisions are made on value. And then other parts of design and development, if we can really understand when a building's being used, the level of energy, the times it's being used. So for example, if we knew that certain floors were used at certain times, we could maybe turn them off at different times to reduce costs. If we knew the level of occupancy, some floors have only got 5 people in them, or some in February they're always very busy, or particularly in this world of hybrid, that we know that on a Monday and Tuesday, lots of people come in. On a Thursday and Friday, generally people might have an extended weekend. So we start to understand our buildings more. But with that, we haven't got a great deal of historic data in the past. Our development team are looking at augmented, so artificial intelligence at the moment. And one of the biggest challenges is just getting existing data from any time going backwards, it is very, very difficult. With digital twins, we can get down to real detail and we can understand not only how a building is used in a floor plate, we can understand how space is used within that floor plate. So we can test. So for example, which side of the building, is it the north or the south that people prefer to sit on? And what times of day do people sit in certain areas? What's important to them? What's the most favoured lux level? All of these sort of things now we can really optimise with our buildings. I think the post-pandemic world has made that even more important. So as I mentioned earlier, there's a lot of space not being used, which means we're heating and cooling spaces that are underutilised. We've had situations recently where we've been able to see buildings which are haven't been commercially occupied, with all of the temperature levels up 24 to 26 degrees and the buildings are empty. And then building floor plates, maybe as we move into the future that we need to design workspaces, for example, differently, that they are more dynamic, that you can open up a total floor plate or you can just heat half of it. And as you understand how the building's used, you can set up the space differently. So you can have one half heated maybe and one half not, because you've got a good idea when these spaces are going to be used. So it can be a lot more specific about how we heat our buildings rather than just heating them, all of that 10,000 square meters I mentioned, heating them all at 22 degrees for the entire day and sometimes at weekends and even into evenings. But as I said earlier, there's a huge disconnect if we're trying to achieve that between the designer and the operation side of things, the operational side, or who we may call the FM provider. And I think going forward with more data, those two sides need to come together as there a greater understanding of that 28% of carbon production coming from buildings. I think there's a lot more understanding and the importance of that connection. And then I talked earlier about the performance of equipment, and an interesting idea there might be that we have something like a TripAdvisor or the kind of car reviews that we have, that there might be certain bits of equipment that we know, for example, a Hitachi piece of equipment is super efficient, or another manufacturer continually fails. And I think if we can feed that information back, it's getting, as we know more about our buildings, their performance and data, we can start to share that. And then, business productivity and business performance. The buildings are not only about the hard aspects of facilities management and energy. A building that has the right environment, it's got the right air quality, can help a business perform well. And I think also an important thing that we've seen over recent years is that millennials and particularly Generation Z have got the importance of sustainability is right at the top of their agenda. They don't want to see buildings that are wasting energy, and they want to understand that they're working in spaces that are not wasteful. So what does this mean for buildings if that's sort of where we are now? How do we need to think about buildings in the future as we move forward? And it certainly needs to be different from how it is now. But fortunately, I don't know who the quote is, we have the technology, the technology is there now to do most of these things. And I stumbled across this quote when I was sort of thinking about what I was going to say today. In God we trust, all others must bring data. And I really like that, particularly in relation to buildings, because traditionally we haven't had much building about our data. And going back to an earlier slide, that actually the best data we have is our electricity and gas bill that we get once a quarter. And they always complain it's just too high, but we still pay it. So one of the things to think about is that we live in a world now where we want to be in the perfect environment. So we want to be in this bubble of 22 degrees Celsius that's absolutely perfect, never changes, there's no drafts, it's just an imperfect environment. To achieve that costs a lot of money. And interesting, we were looking at a building recently where it had been it was a listed Georgian building. It had had very little ventilation in it for over 100 years. It had a wet heating system, and then it got refurbished, and then all of a sudden there's huge amounts of plant go in, air, all this sort of thing, and it just increases the energy cost. But you could argue, well, the building's lasted for 100 years and it's been fine before, but now we all want to live in this perfect 22 degrees world. What if we actually just put up with once in a while it was drafty, or once in a while we got hot, but actually most of the time it's fine. And I think that's something that we need to think about. We've created the expectation of the perfect environment. And then designing for the future, how sort of how could we think about space in the future? And I often think that the first place to start is, do we need a building in the first place? And that's from an architect saying that, and my architects colleagues always look at me strange when I say that, but that's got to be the starting point. Do we need the building? Because when you're making those decisions, they're significant. That's a lot of carbon you're going to be using in construction and in operation. So do you actually need the building? And then even if you do need a building, do you need to build a new one? Can you repurpose an existing one? So I think we need to do more analysis rather than just jumping in. Generally, in most cases, there's a strong reason for a building, and usually when someone's thinking about a building, the need will be there. But interesting, I was reading at the weekend that Currys are one of the first buildings to sell off their headquarters, and they won't have a true headquarters building. They are going to rent off WeWork, and they've given all of their people access to WeWork offices. And maybe that's what the future is going to be like, that the businesses need more flexibility, so they no longer have a 25-year lease. They've got a lot more flexibility. So, you know, in their situation, they've asked that question: do they need a building? And actually, they've come to the answer, no, they don't. So that's a huge change. So then the next one is, you know, if we're looking at the future, how much space do we actually need? The days of saying that, you know, everyone needs 7 square meters is not there anymore. We really have to understand what hybrid working means. And certainly I know from our business point of view, we are hybrid, where we've got 2 days in, 3 days wherever you want to be. But what I find tough is going in and seeing a half full office space where I know we're heating it. And I think that's where businesses will start to reflect and see how they can manage their space differently. And then sort of just following on from that, and the sort of do we need a building part of things, I always say the best engineers design out the engineering. I guess from an engineer's point of view, it's very easy to put plant in and to put ventilation and put lots of engineering in. Actually, the cleverest ones take out that engineering. So if you're even thinking about a structural engineer, it's easy to put a big column in. It's the really tough bit is to design it where it's really super efficient. And I think the same goes for all engineering. And then also from a design requirements in the future, rather than just guessing the amount of space or the temperatures or things like that we need, we're going to have a lot more objective data from these IoT devices connect to digital twins, so we can really make some informed objective decisions rather than just guessing and hoping that we've got it right. So sort of coming back to those 4 areas, this is, you know, I'm not going to go through it again, but the digital twin gives us the opportunity to understand more about those 4 areas, about operational performance, productivity, how we use our space, and then the sustainability, just by having more information, you know, a step beyond our annual utility bills. And then where we get to, when we do bring all of that together, and we've got a lot more data as we build it, as I mentioned earlier, that artificial intelligence gives us the next level of understanding of our buildings. We're going from not having a great deal of understanding now, but if we can get computers to start to do that thinking and learning on our behalf, we will make them even more efficient by taking in lots of different aspects. And I think that's the holy grail. And certainly I know a lot of companies, ourselves included, we've got a team of data scientists who are looking at algorithms and how they bring all of that data together. But again, as I said earlier, the biggest challenge is that there isn't a great deal of data to access out there. So then sort of just to wrap up, just some thoughts for the future and things that takeaways maybe, and a summary. So I think the first thing, we need to understand and learn how our buildings are used. So it's that you understand them, but then also, even when we do understand them, learn for future buildings, and even optimise the buildings that we have now. The next question is this whole thing around environmentally controlled buildings, where there's absolute perfection of that 22 degrees, that has to be like that 24/7. So could we look at changing our set point? So at the moment, it's something around, you know, as low as 21 up to 23 for when our plant kicks into action. But could we take that down to 19 degrees or even lower, or could we go up to 24 degrees? In the summer, would we be okay just to take it as a little bit of uncomfortable one or 2 days a year? Because actually, in reality, certainly in the UK, certainly the high level, there's not that many days where it becomes particularly uncomfortable in buildings. And then probably the most important things, which again is probably unusual we think strange from someone who is heavily involved in a technology business. We would always say technology is the last thing. I think probably the hardest thing, and we found this with our business, is around the culture. So the first thing is, from a building user, is to get that culture aspect right, to let everyone know that the information that I've been sharing today, the impact that we all have in the spaces that we use and the energy that we use, the impact on the environment, the cost to a business. So getting that culture right. Once you've got that, the tech is an enabler of delivering that culture. And then one of the things I've done, just as a little bit of a flavour of the kind of things we're doing as a business. We've got hoodies now which say saving the planet one hoodie at a time. And what I try and encourage people to do when they say it's a bit cold, the answer is not a piece of very sophisticated technology, is just to put your hoodie on, and when it gets hot, take your hoodie off. And I think, if anything, that just sets the tone of what we want to do as a business, and how we want to, going back to those very first things, we want to reduce the amount of carbon, and we want to reduce the costs that our buildings use. So that's my presentation. I'm happy to take any questions if anybody wants to put those in the chat. If anybody's got any, I'm happy to take those if there's any questions. Okay, if there's no questions, you can contact me by email. If you have got any questions afterwards, certainly contact me by email. I'm very happy to have a discussion. As you can probably tell, it's an area I'm particularly passionate about. I'm keen to get other people's thoughts, or is anybody doing anything that we're not doing, or any ideas they've got. We're very open to discuss those, but it's certainly an area that we're going to see more about in the years to come. Just got one question there. So how quickly is it until we begin to see the opportunities after integrating a digital twin? I think the reality of this is that it doesn't happen quickly. This is not a quick fix, but certainly from our point of view as a business, we've seen value from just understanding where we're using our energy. And it's as simple as, once they've found out that, we started turning off the lights in certain areas, even finding out that certain floor plates from our clients are being had the lights on 24/7. So we tell them, so actually the savings can be quite quick if you just at the simplest level, turning lights off and turning the heating down. Okay, well, thanks for listening. Last one from Mark there. From Lee. Are people looking at design for performance, Neighbours UK accreditation, as this is one way of stimulating energy use? Yeah, thanks for that, Lee. That's a good question. And actually the answer is neighbours seems to be really popular. Certainly we're seeing a lot of our partners in London are really picking up the neighbours approach. It seems to be the preferred. I know it's BRE, or BS, British Standard, are now managing it in the UK. I know it's come from Australia. And we've developed a dashboard which helps our clients to manage at a neighbours level. So yes, that is it's really useful because it makes energy use objective, and it's another method of monitoring it. So yeah, we're a big fan of neighbours, but it's complex, but we think it's a really important methodology going forward. I've got a comment from Mark there. Can you only implement a digital twin to a new building? No, absolutely not. Digital twins are very important in existing buildings, and if anything, are probably more important in an existing building, because we haven't got the chance necessarily to adjust the energy use. So the digital twin will help focus on any retrofit requirements. So yeah, it can be used on existing. So a good example again is our office building, Spaceworks, which is a mid-90s building, not particularly energy efficient from an insulation point of view, but really understanding where we're using our energy was a really helpful exercise. Okay, thanks for everyone. Thanks for your questions at the end there. That was really, really good, but happy to keep in touch with everyone if you've got any more questions. But yeah, thanks for listening.